Insulin resistance is a condition where cells in the body fail to respond efficiently to insulin. Insulin is a peptide hormone secreted by the pancreas. It promotes glucose uptake by peripheral tissues such as muscle and adipose tissue to reduce blood glucose levels. Initially, when cells become resistant to insulin, the pancreas tries to compensate by producing more insulin to maintain normal blood glucose levels. However, over time, this can lead to prediabetes, type 2 diabetes, and other metabolic disorders. Insulin resistance is associated with various factors, including the following: excess caloric intake and obesity. High intake of processed foods, refined sugars, and unhealthy fats lead to excess fat accumulation, especially visceral fat. Visceral fat releases inflammatory cytokines and free fatty acids, which interfere with insulin signaling. Inflammation and oxidative stress. Chronic low-grade inflammation activates stress pathways that impair insulin receptor function. In addition, increased oxidative stress damages insulin receptors, reducing their sensitivity. Mitochondrial dysfunction. Impaired mitochondrial function reduces the ability of cells to oxidize glucose and fatty acids, leading to insulin resistance. Hyperinsulinemia and downregulation of insulin receptors. Chronic high insulin levels cause a desensitization of insulin receptors, further worsening insulin resistance. Whatever the mechanism involved, insulin resistance can lead to various disease conditions, including prediabetes and diabetes, cardiovascular disease, non-alcoholic fatty liver disease, polycystic ovarian syndrome, and increased risk of cancer. So, in this video I discuss 6 foods to reverse insulin resistance along with their physiological basis. Number 1. Cinnamon. Cinnamon is rich in polyphenol and cinnamaldehyde, which enhance insulin receptor sensitivity. In addition, compounds in cinnamon activate insulin receptor kinase and inhibit insulin receptor phosphatase, improving glucose uptake by cells. Moreover, they help reduce postprandial blood sugar spikes by slowing gastric emptying. Studies show that consumption of cinnamon daily can significantly lower fasting blood glucose and improve insulin sensitivity. Number 2. Turmeric. Curcumin, the active compound in turmeric, helps reduce inflammatory cytokines that impair insulin signaling. It also enhances the activity of a protein called AMPK, which improves glucose uptake by muscles. Studies have found that curcumin supplementation reduces the progression of prediabetes to diabetes by 100% over 9 months. Number 3. Leafy green vegetables. Leafy greens such as spinach and kale are high in magnesium, which is essential for insulin receptor activation. They are rich in antioxidants such as lutein, zeaxanthin, and vitamin C, which help protect insulin-producing pancreatic beta cells from oxidative damage. Leafy greens also contain nitrates, which improve endothelial function and insulin sensitivity. Number 4. Berries. Berries such as strawberries, blueberries, blackberries, and raspberries contain anthocyanins, which improve glucose metabolism and reduce oxidative stress in insulin-sensitive tissues. They inhibit digestive enzymes such as amylase and alpha-glucosidase, slowing carbohydrate absorption. They also enhance the expression of glucose transporters in cell membranes, facilitating its uptake. Number 5. Fatty fish. Fatty fish such as salmon, trout, sardines, and mackerel are rich in omega-3 fatty acids, which help reduce oxidative stress and inflammation. Eating fatty fish regularly helps lower the levels of triglycerides and free fatty acids, preventing lipotoxicity-induced insulin resistance. Moreover, regular consumption of fatty fish improves endothelial function, reducing vascular complications of insulin resistance. Number 6. Nuts and seeds. These are high in monounsaturated and polyunsaturated fats, which improve insulin sensitivity by reducing inflammation. They contain fiber and plant-based proteins, which slow glucose absorption and improve gut microbiome diversity. Moreover, they provide magnesium, an essential cofactor for insulin signaling pathways.